This last little string of problems, these seem to be the most common questions I get in this section each year. So the little trick I'm going to use, I'm going to set each one of these equal to n. This is also something I'll use in the proofs in the next section, so you'll get kind of used to this idea. Because it must equal something, I just need to figure out what that is. But I am creating an equation this way, because I'm saying it equals this variable n. So if I can solve for n, I should be able to reduce this down, and I think it just makes it an easier way to go. All right, well, I've got e to the log 1.8 equals n. So two ways to think about it now. You can apply these rules you just learned and take log of both sides. Log cancels out n, or at least natural log. Or think about rewriting as a logarithm. If I do e to this power equals this result, I can say log base e, which is natural log, of this result equals the exponent. So however you get there, you're going to get log n equals the exponent part, log 1.8. I think once you get there, it's pretty straightforward, because the only thing that's going to work to balance the equation out is for n to be 1.8. And that verifies that, well, that's what the whole thing had to have equaled in the first place. Ultimately, what's going on is e to the log cancels out, but that's probably not super straightforward to see, but this verifies. This is like a little mini kind of a proof that shows that that's what's going to happen, that e and the natural log cancel out. If we want to make this a proof, all we have to do is say e to the log of x equals n. And if I can prove that n equals x, then that means whatever I put in here has to equal the same result. And I think we get there pretty quick, because it's all the same stuff. Log n would have to equal log x, and the only way these things are balanced is if n and x are the same. So that's a little proof right there that when you do e to the log, they cancel out one another. And what you're left with is whatever was in the, whatever you were taking the log of right there. But that'll be a rule that you can kind of use as we move forward, and you don't have to do all the work for it every time. All right, this one kind of relies on a little trick. Actually, it's worse if I set it equal to n and go that route. It's doable, but there's some little things you got to really look out for. So I think the part I want to focus on is right here, and that's the log of 1. Now, this is something moving forward that you should be able to answer just right off the top of your head. You should be able to tell me what log of 1 is, and if you do know what it is, that's great. You shouldn't have to reach for a calculator to do that, though. So I'm going to take just this part, and let's see if we understand what that is, because this is e times log. It's not e to the log, so they don't just cancel out. So let's see what we can do. Log, this is really base e, so that means that e to the n power would be 1. And I think this is just the easiest way to think about it. I mean, what is the only power you can raise anything to, and your result is 1? So hopefully you're okay with this idea. N would have to be 0. That's the only power that anything can be raised to, and the result is 1. And we've talked about y at this point, so hopefully you're kind of okay with that. If you're still not sure, you can always ask me, and I can give you a little refresher on it. But log of 1 is 0, and that's something you really want to get to a point where you just know that. That's just common knowledge to you, that log of 1 is 0. And then once you get to here, then that's real easy, because e times 0 would be 0. So your final result for 85 is 0. 87, this one's really messy. It's got a lot of pieces going on. So I'm going to take that same approach. It equals something. All right, let's go with that. So natural log means log base e of all this stuff. So it means I could rewrite this e to the n equals e to the log of e. So again, it's just rewriting this, thinking about how natural log is log base e, so e to that power is equal to this result right here, because that's what you're taking the log of. So that leads us to this conclusion. N would have to be log of e, because the only way those are balanced out is if these exponents are exactly the same. So now we've gotten this far. N is the same thing as log of e. Well, we can probably kind of go with that idea that these cancel one another out, and that's e to the first. That would be okay with that. But while I'm continuing this converting sort of idea, this is log base e, because it's natural log. So I can do that again. E to the n would equal whatever's in here, which is e. And if you want to put that understood 1 there, you could do that. So n would have to be 1. So you may have even got, at this point, you may have recognized that. But ultimately, all of this stuff does equal 1. All right, 89, we're talking about the domain of this function. It's log of x minus 1. So the actual domain part's pretty easy, but I want to make sure you understand why this is true. So I'm going to just do it. And then if you're asking, wait, well, why do I know that's possible? Then I'll get to that part in a second. So what I do know is that x minus 1 has to be greater than 0. Not even equal to, just greater than 0. So x is greater than 1. That's my domain. All right, so it's a piece of cake to do that part. But you got to make sure you understand why that's true. So let me give you sort of a simpler example here. Let's just say y equals log x. And I just want to see what the domain should be on that. So let's rewrite it. E to the y equals x. Now I know this is backwards from what we usually do. And we could probably go as far as doing the inverse so that we're dealing with exponential equations, and that's fine. But I'm gonna stick to this for now. So do a little xy table here. And we're going to do it kind of backwards, and we're going to do it in kind of a bizarre way. So I want you to consider 3 things. What if y is positive? What if y is 0? And what if y is negative? And I know it's a little less specific than what we usually do, and it's also plugging in y to get an x, which is way backwards, but just run with this and see if it makes sense, because I think this will explain everything. So let e get raised to some positive number. Make it 1, make it 10, make it 1,000,000. X is going to be a pretty big positive number. I'm pretty confident about that. And if you want to say large, that might even make you feel better. All right, let y be 0. Well, e to the 0 is 1. Anything to 0 power is 1. Okay, now let y be some negative number. So -1, -2. And if you're having trouble thinking about e, this could work if it was, say, 2 to the y. Everything I've done here would still hold up. So if it's raising e to the y is kind of throwing you off, we could just raise a number to y, and it would still, all this stuff would hold true. So raise 2 to the -2, well, that's 1/4. Raise 2 to the -3, that's 1/8. To the -10th, that'd be 1 over 1,024, I think that's right. The point is, if you raise this to a really big negative number, you're getting a really, really small fraction. But you're never going to get to 0. So you get a really small fraction, but it's always a positive fraction. So here's the scenarios. You plug in a positive number for y, you get a big positive number for x. Plug in 0, you get 1. Plug in a really huge negative number and you get a really small positive fraction, but still never 0. So the point here is your x value will always be positive. You can't take the log of a negative or 0 because, think of the inverse, there's nothing you can raise a number to that will produce 0 or a negative. And since that's impossible to do, at least in real numbers, that's why you can't take the log of 0 or a negative. So whatever's in here you're taking the log of, it's got to be bigger than 0. So really, as far as the domain, that's all you got to do. But I think it's really good that you understand why that's happening. 91, the domain of f of x equals log of -x. So off that case we just talked about, we know that -x has to be bigger than 0. So there's one little trick here I want to make sure that you're okay with. And to solve for x, you got to multiply by -1. I even mess this up sometimes. It's real easy to do. Because I multiply by -1 on both sides, that switches the inequality. So x is less than 0, that's my domain. Now just in case, I just want to show you how this works, just in case you're not familiar with why that rule works. Because honestly, I had accepted that for a long time, and I'm sure someone explained it to me really well, and it just, for whatever reason, didn't stick with me. But I was actually teaching this when it dawned on me, or I think someone explained it to me why it works. It's so simple. So back to here, again, if you're not really 100% sure of why switches, why the sign switches magically when you multiply by -1. We just solve this by addition. I couldn't believe how simple this was. I thought, yeah, it's pretty straightforward. So then that becomes 0, and then x is over here, and boom, there you go. X is less than 0. So either way you go, you get x is less than 0, that's your domain.